Hello friends, welcome to the new video lecture. In this video, we are going to see the velocity analysis by instantaneous center method. In my previous video for velocity analysis, I have done relative velocity method, for which you can find the link in the description box. If you haven't seen that video, please go through that video by clicking the link in the description box. Okay. So in this particular video, we are going to see the instantaneous center method for velocity analysis. So before going into the deep of this topic, let us first understand what is instantaneous center. Okay. In our practical day-to-day life, we see most of the objects or links performing combination of motion. Okay, like the wheels of a train does translatory and circular motion, rotation motion at the same time. Like many more examples, we see which does the combination of motion. Okay, so here also we are going to see an example of a combination of motion, that is a rotational motion and translational motion. Okay, now see, if I take a link AB, this is the initial position for the link. Suppose the link initially does a translation motion, okay, in this direction, and it reaches up to here, and now it does rotational motion and it finally reaches up to here. So this is the final position A dash and B dash. Okay, this initial to final position has been reached by first doing the translatory motion, then doing the rotational motion. Okay, this can also be done by first performing the rotational motion, then by translation motion, followed by translation motion. Okay, so this is the initial position, that is AB. Okay, now it does the rotational motion and it reaches here, and then it does translation motion and it again reaches here. Okay, so this is A dash, B dash. So initial and final position, if you see the initial and final position, this can be achieved first by translation, then by rotation, or by rotation, then by translation. Okay, so this initial and final position can be achieved by this method. Okay, now most of the practical examples are like this only. We see the combination of motion and not only the single motion. Okay, but when we do velocity analysis, we eliminate this combination of motion and we only see a single motion that I'm going to explain now. Okay, so if I see at any instant, this is the initial position AB, and this is the final position, that is A dash, B dash. I'm not showing the combination of motions or the motions that are happened between this initial position and final position. We are only seeing at particular instant the initial position and the final position. Okay, so in order to do the velocity analysis by instantaneous center method, we assume that this motion has been achieved by a pure rotational motion. Okay, eliminating the combination of motion between that, we assume that this motion, this initial to final position, has been done by pure rotational motion. Okay, concentrate that only single motion is considered, that is pure rotational motion. Okay, now this motion is done about a center which is known as instantaneous center. Okay, now this is the circumference, I can say, okay, part of circumference, and this is the chord that is joining the initial and final position of this A to A dash, B to B dash. When we draw perpendicular to this chords, this is the perpendicular and this is the perpendicular. Okay, so this is perpendicular to this chord and this is perpendicular to this chord. When we see the intersection point of this perpendicular lines to the chords, then this is the center about which this rotational motion is happening. Okay, so instantaneous center can be defined as, this is the virtual center, this is the virtual center about which pure rotational motion of any object or link is assumed. Okay, again I'm repeating it. Instantaneous center is a virtual center about which the pure rotational motion of any link is assumed. Okay, eliminating the combination of motion. So this is the instantaneous center that we are going to study. Okay, so in any mechanism, 4-bar mechanism, 3 sliding mechanism, any mechanism, we need to find the instantaneous centers. Okay, and after that we need to solve the process. Okay, and we need to find the velocity of any point or angular velocity of length that we are going to see in our next videos. So I hope you understand what is instantaneous center before moving to the deep of this topic, instantaneous center method. Okay, so we'll continue how to find the instantaneous center for the link or a mechanism in our next video. Okay, till then, thank you.